It's pretty amazing, isn't it? We live so much of our lives online, in the cloud, but printing is still absolutely fundamental.
It really is. For critical documents, for businesses, even for, creative stuff and new inventions, we still need that physical thing in our hands.
Totally. And today we've been digging into a whole bunch of sources, trying to map out this whole world of printers. It's huge. Goes from the little machine you might have at home all the way up to massive industrial tech.
A really wide range.
Okay, let's unpack this. So our goal here isn't just to list off features. We want to go a bit deeper. Figure out the main types of printers, sure, but also understand why you'd choose one over another for a specific job. What are the real differentiators and how they work?
Right. And at its core, a printer is, well, it's a peripheral, isn't it? It
Yeah.
takes digital data, text, pictures, whatever, and turns it into a hard copy.
Simple enough.
But the interesting thing from the sources is how specialized they've become. Each type seems tailor-made for a certain kind of user or situation. It's not random. It's solving specific problems.
Okay, so let's start with the big two, the ones most people probably think of, maybe even have arguments about at home or in the office. Inkjet versus laser.
A classic showdown.
Yeah. So inkjet first. How does that actually work?
Inkjets are all about liquid ink. They have these incredibly tiny nozzles, like microscopic, and they spray these minuscule droplets of ink directly onto the paper. Think of it as a very, very controlled spray paint can, almost.
Spraying liquid. Okay, so that explains why they're good for photos, the blending.
Exactly.
It-
Because it's liquid, it blends colors really smoothly, really naturally. That makes them, well, pretty much unbeatable for high-quality photo printing.
Yeah.
And they handle different paper types well, like glossy photo paper.
Right, and they're usually cheaper to buy up front, aren't they? And smaller.
Generally, yes. Lower initial cost, often
Mm.
more compact, great for home use, low-volume stuff.
There's always a but. What are the catches?
Well, that liquid ink has downsides. They're slower than lasers, for one. The prints can sometimes come out a bit damp, it might smudge if you're not careful.
Mhm.
And the big one, especially if you don't print often, those tiny nozzles can clog up. That's a real headache. Plus, while the printer itself might be cheap,
The ink cartridges, they cost a fortune, right?
that's the hidden cost.
Yeah.
Cost per page can be really high because you're replacing those small cartridges all the time.
Okay, so that leads us to the other contender, the laser printer. How is that different? No liquid ink here.
Nope, totally different approach.
Mm.
Lasers use toner, which is essentially a very fine, dry powder.
Powder. Okay, how does powder stick to paper?
Yeah, it's actually a pretty cool process. It uses a laser beam to draw an electrostatic image onto a special drum, a photosensitive one.
Like static electricity.
Sort of, yeah. That static charge on the drum attracts the toner powder.
Mhm.
Then the paper rolls past the drum, picks up the powder image, and finally goes through heated rollers, a fuser unit, which melts the toner and bonds it permanently onto the paper.
Wow, okay. That sounds much more complex, but faster.
Much faster. That heat fusion process is quick. That's why lasers dominate in offices where you need to print lots of pages quickly. You get really sharp, crisp text and graphics. Very professional looking.
And reliability. You mentioned inkjets clogging. Lasers.
Lasers are generally workhorses. They're less prone to clogging or jamming, especially with regular use. And because toner is used so efficiently, the cost per page over the life of the machine is usually much, much lower than inkjet.
Okay, so the higher upfront cost of the laser printer itself, that's because of all that complex drum and laser and heating tech inside.
Precisely. More complex mechanics, generally larger and heavier machines. It means a higher initial price tag. And yeah, repairs can be more expensive too if something does go wrong.
So, boiling it down. Laser is for speed, high volume, sharp text, lower running costs over time.
Yep. Think office documents, lots of them. Reliable workhorse.
And inkjet is for top-notch color, photos, maybe printing on special paper, lower upfront costs, but higher ink costs.
That's the gist of it. Great for home users, creative tasks where image quality is paramount.
Okay, that makes sense. But the world of printers doesn't stop there, does it? You mentioned solving specific problems. Here's where it gets really interesting. Moving beyond just inkjet versus laser.
Right. We start seeing technologies designed to tackle those core issues, like the crazy cost of cartridges or the environmental impact.
Let's talk about continuous ink or ink tank printers. That sounds like a direct answer to expensive cartridges.
It absolutely is. Instead of small disposable cartridges,
Yeah.
these printers have built-in large ink reservoirs tanks that you refill yourself from bottles.
bottles of ink, like pouring it in.
Yeah, you literally pour the ink into the tanks. It sounds messy, but it's usually quite straightforward.
And the benefit is cost, I assume.
Huge cost savings. The sources mentioned one set of ink bottles can print the equivalent of like 70 or more standard cartridges.
Yeah.
It dramatically lowers the cost per page.
Wow. And better for the environment too, right? Less plastic waste from cartridges.
Definitely a big plus. Keeps a ton of plastic out of landfills.
Yeah.
And you get the same great print quality, often based on inkjet tech, but without the constant hassle and expense of cartridge swapping. Less downtime, too.
Okay, so if the running cost is so incredibly low, why isn't everyone using these? What's the catch? Higher initial price again.
That's the main one. The printer itself costs significantly more upfront than a standard inkjet. It's an investment. And you do have that manual refilling process. It's not hard, but it's maybe not as convenient for some people as just snapping in a cartridge. They also tend to be a bit bulkier.
So it's a trade-off. Pay more now for much cheaper printing later, and you have to handle the ink bottles.
Exactly. Long-term savings versus upfront cost and convenience.
Okay, now what about something completely different? Solid ink printers. You mentioned wax sticks.
Yeah, this was a really unique technology. You'd used solid blocks or sticks of ink, almost like crayons, made from a kind of non-toxic vegetable oil-based wax.
Relax. How did that work?
The printer melted these wax sticks, and then the molten wax was precisely transferred onto the paper. It gave the prints a very distinct, slightly raised, waxy or glossy feel.
Interesting texture. What was the point?
Well, a couple of things. The colors were incredibly vibrant and consistent, and a big selling point was the environmental angle. The wax sticks needed hardly any packaging compared to bulky cartridges, so much less waste. Plus, they didn't dry out.
Sounds pretty good, actually. Why don't we see them much anymore? The sources said they're mostly discontinued.
Yeah, they kind of faded away. They had some drawbacks. They needed time to warm up, to melt the wax, and then cool down. You couldn't easily write on the prints. And critically, you couldn't laminate them because the heat would melt the wax again.
Okay.
And maybe people just didn't love that unique waxy texture for everyday documents. It was a cool idea, great colors, less waste, but the practicalities didn't quite win the market over.
So, a niche that didn't quite stick. But speaking of niches that have stuck around, despite being ancient tech, dot matrix printers.
Oh yeah, the durable relics. If you've worked in certain industries, you definitely know the sound. That screeching, buzzing sound.
I can almost hear it now. So they work by impact, right? Physically hitting a ribbon.
Exactly. It's an impact printer. It has a print head with tiny pins that strike an inked ribbon, pressing it against the paper to form characters out of little dots. Like a typewriter, but with dots.
Which means they're super noisy, and the print quality is, well, pretty basic, right? Low resolution.
Very basic, yes. Definitely not for glossy photos or sharp reports. So why are they still around?
Good question. Why are they still used?
Two key things. First, sheer toughness. They could operate in really rough environments. Dusty warehouses, greasy garages, places where a delicate laser or inkjet would just die immediately. They're built like tanks.
Okay, durability. What's the second thing?
Carbon copies. Because it's an impact printer, it can print on multi-part forms. You know, those forms with layers of paper and carbon paper in between. It's the only common technology that can create those instant duplicates needed for things like invoices, shipping forms, legal documents in some places.
That makes sense. So it fills a very specific, very practical need that other printers just can't. Endurance and function over finesse.
Precisely. And then there's another specialized workhorse, maybe less noisy, but equally ubiquitous in its niche. The thermal printer.
The receipt printer. Every shop counter has one.
That's the one. These use heat. The paper itself is special. It's coated with chemicals that turn black when heated. The printer has a thermal head that applies heat in precise patterns to create the text and images.
Which is why receipts fade if you leave them in the sun or, like, near a heater.
Exactly. The heat-sensitive paper is the key. The big advantages are simplicity and reliability. Very few moving parts compared to other printers, so less to break down. They're compact, energy efficient, and quiet.
Perfect for point of sale.
Ideal. But, as you said, the prints aren't permanent. They fade with heat and light. And most direct thermal printers, the common receipt type, are monochrome, only black and white, essentially. They do their job perfectly for short-term records, but that's it.
Okay, so we've covered the mainstays and the niche workhorses. Now, let's shift gears a bit. Let's talk about printers that go beyond just putting ink or toner on standard paper. Things are getting more three-dimensional.
Absolutely. We have to talk about 3D printers. This isn't just printing on something, it's creating something. Additive manufacturing.
Additive. meaning building up.
Exactly. Instead of starting with a block and carving away material, 3D printers build objects layer by tiny layer, based on a digital 3D model. They use materials like plastics, resins, powders, sometimes even metals or ceramics.
The possibilities seem endless there. What are the big uses?
Oh, huge. Rapid prototyping is a classic. When engineers can design a part and print a physical version quickly to test it. Customization is another. Think custom medical implants, dental crowns, prosthetics tailored to a specific person, and creating really complex shapes that would be impossible or incredibly expensive to make using traditional methods, especially in aerospace or automotive design.
It sounds revolutionary, but are they practical for, like, everyday stuff? What are the downsides?
Well, they're generally slow. Building layer by layer takes time, so it's not great for mass production where you need thousands of identical items quickly.
Right?
The initial cost can still be quite high, especially for industrial-grade machines. And the materials themselves can be expensive. Plus, there are different types of 3D printing, like FDM, which melts plastic filament, or SLA, which uses UV light to cure resin, and the choice affects the strength, detail, and finish of the object. It's a whole field in itself.
Okay, so amazing potential, but still specialized and not exactly replacing the office printer yet.
Not for everyday documents, no. Now, another specialized one that does involve putting images onto things, but not usually paper, is sublimation printing.
Sublimation. That sounds scientific. Turning a solid straight into a gas.
That's exactly it. Dye sublimation uses special solid dyes. When heated, these dyes turn directly into a gas. They sublimate, skipping the liquid phase entirely. This hot gas then permeates the surface of polyester fabrics or specially coated materials like ceramics or metal.
So the ink becomes part of the material itself, not just sitting on top.
Precisely. It bonds into the substrate. The result is incredibly vibrant, sharp, and really durable prints that won't crack, peel, or fade easily like some other methods.
What kind of things is this used for?
Think custom merchandise. T-shirts, sportswear, especially polyester stuff, mugs, mouse pads, keychains, phone cases, even metal signs. Anything where you want a really permanent, high-quality image on a non-paper item.
Okay, sounds great for personalized gifts or company swag. Are there limitations?
Yes, the main one is the material. It really only works well on polyester or items with a special polymer coating. You can't just sublimate onto a regular cotton T-shirt or an uncoated mug.
Ah,
And you typically need two pieces of equipment. The sublimation printer itself to print the design onto special transfer paper, and then a separate heat press machine to apply the heat and pressure needed to transfer the dye onto the final item. So the initial setup cost can be higher than, say, just getting an inkjet.
got it. Specialized but powerful for the right materials. And what about just bigger prints, like for architects or designers?
Right, that brings us to large format printers and plotters, the scale masters, you could call them.
These are for printing big stuff, obviously, like A3 size paper or even much larger, A1, A0.
Exactly. Posters, banners, architectural drawings, engineering schematics, big presentations, things that just won't fit on a standard letter or A4 printer.
And you mentioned plotters specifically. How are they different from just a big inkjet?
Traditionally, plotters were pen-based. They literally drew lines using pens, following vector graphics, mathematical descriptions of lines and curves. This made them incredibly precise for technical drawings where accuracy is paramount, like blueprints.
So no dots or pixels, just clean lines.
Exactly. Nowadays, many large format printers use inkjet or sometimes laser technology, but the term plotter often still refers to those used for highly detailed line drawings in fields like architecture, engineering, and construction, AEC. They offer incredible precision.
What are the pros and cons of these big machines?
The obvious pro is the ability to print large scale. They can also often handle a wide variety of media, different paperweights, canvas, vinyl, even fabric sometimes. The cons: they're expensive,
Yeah.
very expensive up front, and they take up a lot of space. They're definitely specialized equipment.
Okay, let's bring it back to the typical office environment for a minute. We've talked about dedicated printers, but what about those machines that try to do everything? The multifunction or all-in-one printers?
Ah, yes, the MFP or AIO, the
Yeah.
jack of all trades.
They combine printing, scanning, copying, sometimes faxing, all in one box. The appeal's obvious, right? Space saving. Potentially cheaper than buying separate devices.
Definitely. For a small office or home office, they can seem like the perfect solution. One machine, one connection, handles multiple tasks. They often integrate well with digital workflows too. Scan to email, print from the cloud, wireless connectivity. Makes IT management simpler in theory.
That single box sounds like a single point of failure waiting to happen.
That's the big risk, isn't it? If the printing part breaks, maybe the scanner stops working too. Or if the scanner jams, perhaps you can't make copies. When it goes down, all those functions might be unavailable.
So is the convenience worth that risk for a busy office?
It's a trade-off businesses make. For many, the space and cost savings, plus the streamlined workflow features, outweigh the risk of occasional downtime affecting multiple functions. But if printing or scanning is absolutely mission-critical, non-stop, dedicated machines might still be preferred for redundancy.
Makes sense. Now, one last category that often gets lumped in with lasers but is slightly different: LED printers.
Right. LED printers are very similar to laser printers. In principle, they use toner, a drum, and heat fusion.
So what's the difference then?
The light source. Instead of a single laser beam that has to be moved across the drum using mirrors, an LED printer uses a fixed array, like a bar, containing thousands of tiny light-emitting diodes, LEDs, that spans the width of the drum.
An array of lights instead of one moving laser beam.
Exactly. Each LED corresponds to a single dot position on the line being printed. This means fewer moving parts compared to the laser and mirror assembly in a laser printer.
Fewer moving parts usually means more reliable, right?
Generally, yes.
Yeah.
LED printers are often touted as being extremely reliable and durable because of that simpler mechanism. They can achieve high printing speeds, comparable to lasers, and manufacturing the LED array can potentially be cheaper than the laser optics.
So if they're reliable, fast, potentially cheaper to make, why aren't they more dominant than lasers?
That's the interesting part.
Yeah.
Despite the potential advantages, they haven't quite overtaken lasers. One reason is market inertia. The big laser printer manufacturers have huge scale and established supply chains. Also, while LED print quality is very good, some argue that high-end lasers can still achieve slightly sharper text or finer graphics. Because they're less common, finding technicians or parts for repairs might sometimes be a bit trickier compared to the ubiquitous laser models.
So a solid alternative, very reliable, but maybe faces market challenges and niche perception issues.
Pretty much a reliable workhorse, often grouped with lasers, but with that key internal difference.
Wow, okay. We've covered a huge amount of ground. From spraying ink to melting wax to fusing powder to building objects layer by layer.
It's a surprisingly diverse field, so when you pull it all together, if someone asks, which printer should I get?
Yeah.
The answer really has to start with their needs, doesn't it?
Yeah, absolutely. It's all about priorities. Are you printing tons and tons of text documents? Then speed and cost per page are probably key, pointing you towards laser, maybe LED, or definitely continuous ink if you can handle the upfront cost.
Right. Or is it all about quality? Stunning photos. Then inkjet is still probably your best bet, despite the cartridge costs. Or maybe you need something super specific.
Like those multi-part forms that only a dot matrix can handle, or creating custom mugs with sublimation, or maybe even prototyping a new product with a 3D printer.
Exactly. The function dictates the form.
And it's clear this isn't a static industry either. The push towards things like the ink tank systems shows a real move towards, lower running costs and maybe being a bit more eco-friendly.
Definitely. And the constant innovation in 3D printing materials and techniques shows there's still plenty of exciting development happening. It's not just about putting words on paper anymore.
Which brings us to a final thought to leave people with. We talked about those multifunction printers, the all-in-ones, being convenient but representing that single point of failure for printing, scanning, copying, even faxing.
Yeah, the concentration of functions.
So the question is, does centralizing all those critical office tasks onto one single device really increase overall efficiency in the long run? Or, considering that hardware failures do happen, does it just concentrate the risk, making a small problem potentially paralyzing for office productivity? Something to think about next time you're looking at office equipment.